Okay, here's the problem solving video for E2.19 where we're asked to find V0. We're actually going to utilize two problem solving strategies for this one. The first one's on page 53 that's talking about circuits with dependent sources. Also we'll utilize the one on page 36 in regard to single loop circuits. This is a single loop circuit, and if you'll remember, for the single loop circuit, our first step was to define a current, and that current's already been defined as I. The second step was to assign voltages to the resistances using Ohm's law. So for instance, for this resistor, the voltage is 4K times I. For this resistor, the voltage is 8K times I. Okay, now the problem solving strategy for the dependent sources says now apply KVL to this equation. Treat that dependent source as though it were an independent source. So now let's apply KVL. Let's start at this point in the circuit and go around clockwise. If we do, we'll have 4K times I minus 2VA plus 8K times I minus 6 equal to 0. So we applied Kirchhoff's voltage law to the single loop circuit. We treated that dependent source as if it were an independent source. Now, if we look at our circuit, then for instance we can see that VA is equal to 4K times I. So now let's make that substitution. Okay. So now we'll have 4K times I minus 2 times 4K times I plus 8K times I minus 6 equal to 0. And if you'll note, these two terms cancel. We're left with 4K times I is equal to 6. Therefore, I is equal to 1.5 milliamps. So now we solve for the current. And then V0 is 8K times I. So we have 8K times 1.5 milli. And that tells us that V0 is equal to 12 volts.